Now, pyramid shown has a rectangular base, and the point X is directly above the midpoint of the base. So the rectangle at the bottom, X is directly above it. Draw two different possible nets of the pyramid, and hence using one of them find the external surface area of said pyramid. Happy days. To be honest, it's weird for me because I actually only know one of these nets. I don't know both of them off by heart. So the net I usually use is the rectangular base, which is like so. What's it? Rectangular base, and then I'll just go. Whoop, that's another rectangle. Something like this. The triangle on the left and triangle on the right have to match each other size-wise. They're meant to be exactly the same size. I know they're not. And then you notice that the triangles aren't all the same size, are they? They're in two pairs of two, isn't it? So this one's going to be. Now, what's the one size they have to have in common? What's the one thing they have to have in common size-wise? Dead center has to be the same. That should be the same height. Does that make sense? Otherwise, they won't match at the very top. Right, and then on the bottom. Now that's one possible net. That's my preferred net. Anybody know the other one? Pretty killer.
Draw a rectangle and then draw a triangle attached to each other?
Yeah. So draw this rectangle here. So I'll just clone this. I'll just clone that one. Okay, Control D. Draw that rectangle there. Draw a single triangle. So draw this. See this triangle here. All right. And then the other two, because they meet on top of the pyramid, you can draw it like that, linked up, sort of like this. So if you were to label them in the first one, that'd be side 1, side 2, side 3, 4, and 5. That's still 1, that's still 2, that's 4, that's 5. And what's the only one I'm missing?
3.
Missing number 3 down here. Is that okay with you guys? So there are your two nets, okay? Now I'm going to go back into my first one, my first net, which is my preferred one, and we're going to try and figure out its size. Where's the easy marks located? 15 and 10, which is 150. Okay. Now let's go for triangle A. They're the same size, aren't they? Now what can we say about triangle A? Alright, so picture this. See this side here? Ever see that side there? Where's that located on this diagram? I think it's this one. So everyone happy that it's that one there? Okay. Now I'm about to show you a trick here. Alright, here's the trick. What I'm going to do is I'm going to get this length here. And anytime you do a pyramid question, it's always the same trick. You're going to go after this line here. Does anybody know the length of the green line? And if you want to see the green line, on the original diagram, that's it there. Wait a minute. That's it there. Alright? And if we get the midpoint of the green line, we get what's directly underneath the tip of the pyramid. Is that okay? So what are we going to say there for that? It's going to be, we call it X, so it's going to be 15 squared plus 10 squared equals X squared. And what's 15 squared? Is it 225? 325 equals X squared. What's the square root of 325? Good energy, lads. 5 root 13 or 18.03. Alright. Next part. How am I going to convert this information into finding out what is the height of the... how am I going to convert this information into finding out what the purple line is? I want to get that purple line. How am I going to get it? Right? I'm going to drop a red line. The red line drops from the top of the pyramid straight into the middle. Does that make sense? Top of the pyramid straight down, okay? Now I'm going to make why is this a right angle triangle? Why does the purple, the green and the red make a right angle triangle? Can anybody tell me?
Green is perpendicular to the red.
Green is perpendicular to red, okay? What's that? That's black. Green, red. Is everybody focusing here, or are we just giving up already? You know who you are. Purple. Alright? Now what next? Okay, guys. What do we say here then? What size is the green? It's not 5 root 13. It's half of 5 root 13, which is, just call it 2.5 root 13. What's the height of the red one? They gave that to us, didn't they? And we call the purple one y. So that's we're going to get y squared equals 14 squared plus 2.5 root 13. If somebody wants to square that out and tell me what it is, that'd be awesome. Anybody? Big Mick?
I didn't do it this way.
277 and square root it. 16.65. Right. Yep. Does everybody have it at 16.65? Okay. Now, we're sort of lucky here. 16.65. What do we know about the purple line? What do we know about it? Is it shared with another side?
Yeah, the opposite. Big one, big triangle. Same with all of them.
Yeah. So it means no matter which one I do, it's always going to be... Sorry, I think I said something earlier. Do you remember we said that we thought the vertical heights have to be the same? They can't be. It's the slanty edges that have to be the same height for it to fit together. So some of them will bend further in and some of them will be more straight. So it's actually the slanty edges, because they're shared edges. That's what I meant. They're the ones that have to be the same size. So this means everything's 16.65. That's 16.65. That's 16.65. That's 16.65. Even though it doesn't look like it. Okay? Now we've got to find the area of all of these. So we just do a half. So we're going to have to do Pythagoras' theorem, aren't we? So Pythagoras' theorem we're going to use to find the red lines, which are, this red line is the perpendicular height, and run out colours here. We'll go for this yellow line is the perpendicular height of that one. So that's what we're going to try next. Okay. What's half of 10? Lads, we're aiming here. What's half of 10? 5. So we know it's, we call this h squared plus 5 squared, because that's 5 and that's h, and that has to equal 16.65 squared. So do me a favour and find out what h squared is. 16.65 squared, take away 5 squared and square root your answer. If you get it, let me know. 15.88. Okay, that's the red line. Now we're going to figure out what the yellow line is. We'll call this distance d. What's half of 15? So what we're going to do here, d squared plus 7.5 squared equals, so Charlie, square 16.65, take away 7.5 squared and square root your answer.
Uh, 14.8.
Is everybody happy with these? 14.8? Okay. 14.8. Shocking. 14.8. And the other one's 15 point. The other one's 15.11. Or say 15.88. Okay. Now, here's what we're going to do next, lads. Going to rub out a bit of this. You rub out pretty much everything we don't need. Now, we know that's a base of 15, don't we? And we know this is a base of 10. So a half base times height. A half 10 times 15.88. How many of them is there? How many of those type of triangles is there? There's 2 of them, isn't there? And then what about the other one? A half 15 times 14.8, and once again we're going to multiply that by 2. Does it want us to include the rectangular bottom? I would actually add in the rectangular bottom, because if you imagine you were painting a pyramid and like it does like an ornament, you could flip it around and paint the base, couldn't you? So if it didn't specify otherwise, I would also include the 150. What answer did you get when you lobbed that all in? Was there a general answer we should get for this? Let me look it up here. I'm hoping for 532. Is that it?
Yeah.
Happy days. Alright, who got it? It was tricky. Yeah, tricky stuff. And then, yeah. Now, if x, y, and z represent lengths, and pi and a are numbers with no dimensions, pi and a means they're not like meters or centimeters. They're just a constant. All right. So state whether each of the following formula represents a length or not. All right, that's handy. Pi times a length squared. Centimeters squared. So what do you think the first one is? Area. First one represents an area. What's AX then? That could be, that's just centimeters, isn't it? Because there's nothing squared. And here, I'm going for length for the second one. The third one, lads, just a number multiplied by centimeters multiplied by centimeters. Area, because it'd be centimeters squared. So C is area. What about D? Constant, and then centimeters. So it'll just be a length. What about this one here? A is just a regular number. X is centimeters. Y is centimeters, which would be centimeters squared. Area. Next one. Is it both? They shouldn't be mixing the two then. Let me have a look. Yes, that's very unusual. Oh, sorry. A combination of both. Sorry, so this one is area and this one is length. What about AX plus XY? That's centimeters squared, that's centimeters. That's a combination of both. Brian, the next one. AXYZ. Centimeter by centimeter by centimeter. Volume. Alright. Last one. X squared Y. Centimeter by centimeter by centimeter, which is centimeter cubed. That one's a centimeter cubed as well. And the third one's a centimeter cubed as well, which would be a volume. That looked really, really difficult, but it wasn't too bad. Now, yes, a rectangular storage box. Alright, gents, lads, how do we get the volume of a storage box? Okay, so what do we get? Ben, what you get for this one? What you get for it? Just 122 by 75 by 53. So have it done? Okay, that must be it. Okay, now, lads, that's how much volume we got. Okay, now what's the error? So take the two of them away from each other. So what's the error? 5,000. Oh, sorry. It's just 50 centimeters, is it? So your error. So your percentage error is your error over your true value. It's your error divided by your true value multiplied by 100. Which one's the true value? The one we calculated, wasn't it? And then we multiply that by 100, and what do we get? Huh? 0.0%. Not even 5%, just like 0.01%. That's small. Fair enough. If the measurements are taken using a ruler, scaled in centimeters, find the tolerance interval for the volume of the box. That's interesting. Is that, for me, that's find the lowest value and find the highest value. I'll just check it now. Yeah, it's exactly what I was thinking. Lowest value minus highest value.
What makes you say that you find the highest value?
So I'll show you now. So when you measure this in centimeters, okay, you round up. So if you go from, oh look, I have a ruler, happy days, right? So if you measure this and you have to round it up, so let's say for argument's sake I have a measurement here. 4.5 gets rounded up to 5. So the smallest value this could be is, for argument's sake, what's it? Scaled in centimeters, right? So the smallest value this one could be is what's 121.5. That's the smallest value it could be. What's the smallest value 75 could be? Smallest value this one could be? Is that okay with you guys? Oh, sorry, 52.5? Okay. And what do we get there then? Multiply all that out and you get 45216.875 centimeters cubed. Now, likewise, what happens if you had for argument's sake, 122.4999999. Where does that go? Up or down? Goes down. But essentially it's 122.5. You're not going to write all those decimals, are you? So you're sort of approximating this. Technically I'd be inclined, I would have liked the question to say 2 decimal places. I would have went 12.49. Do you know where you'd round it off to the nearest millimetre? But the solution has it as 0.5. Okay, so they must have done what I'm thinking. 4999 is your maximum value. Hell, it's practically 0.5. Okay, so here's what we're going to do. There's not enough of a difference to warrant worrying about it. So it's going to be 122.5. Next one. Next one after that. Now, I know all of these are meant to be rounded up, aren't they? They're all meant to be rounded up, aren't they? But for argument's sake, it's 49999. That's what they're taking it as. They're just saying 0.5 is a better measurement. Throw all that into the calculator, and what do we get?
4948.125.
Yep. Now, lastly,
Around 25, I think.
what'd you say?
I think it's 25, not 825.
Solution says 0.875, but I think you might be right though. I think it backs out on itself afterwards. Yeah. You can put it in the calculator to check it out, but I think you're right with that, Mick. I think the solution made an error there. Okay. Just multiplying it out anyway at the end of the day. Now, what is what is tolerance? Alright? So let's break this down to a really easy example. Imagine you got 70 on one measurement, 80 on the other measurements. Do you know what your tolerance would be? You get the middle. So you get the average of your two values. What's the average of your two values? 75. And how far is 75 away from your two values? So your tolerance would be 75 plus or minus 5 centimeters. So using that logic, what you're going to do here, you're going to get the average of the two of them, and then plus or minus the gap from your average to one of the values. Does everybody get what we're doing there? No? Alright, Barry, one more time, alright? Barry, imagine I did two measurements. This is measurement A and this is measurement B. Imagine it was a really easy example. Measurement A was 70. Measurement B was 90. Okay? You add A and B together and divide by 2. What do you get, Barry? In the easy one. 70 plus 90, I mean. What do you get? 80. 80 is your true measurement or your best reflection of a measurement. It's halfway between your minimum and your maximum. How far is 80 away from your minimum and maximum value? Exactly. So I could write this answer. My tolerance interval is 80 plus or minus 10 centimeters. Okay? How would you do it for the numbers on the board? What would you do? You'll add A and B together and divide by 2. And when you add A and B together and divide by 2, what you get? Make them hoping it's 485 012.5. Alright? What distance is this measurement away from B or A? Any idea, Mick?
9795.65.
95, yeah, 0.625. Does everybody get that from the smaller measurements? What exactly you're doing? Okay, and it's centimeters cubed. Alright, happy days. On to 13. Whew. Another pyramid. Loving this. The formula for the volume of a pyramid is a third the base area multiplied by the perpendicular height. Fantastic. For the square base pyramid opposite, find the volume in terms of A and H. Alright. Can I use the formula? That's handy. Okay. What's the area of the base? Yeah. A third A squared. And what's the perpendicular height? H. Done. Find the volume of the pyramid if the length of the base is 6 and the height is 7. Well, that's fierce handy as well. 84 centimeters cubed. We all good? Right, let's move on. Another square base pyramid has a base length of 5 and a volume of 100. Find its perpendicular height. Alright, no bother. Last time I checked, it's a third A squared H, which is going to be 1/3 5 squared multiplied by H equals 100. 300 divided by 25, anybody? 12. Anybody get a H value of 12? So H on its own, or 25H equals 300. H equals 12. Hence, by drawing its net, find its total surface area. Should I really do another one of them? Or are we all good? What did we have to find last time was the most difficult part? Is this? Oh, sorry. That's a triangular base pyramids. Alright, just give me a sec. That's a diagram there, is it? Okay. What do we say the base is, Mick?
5.
Base is 5. What did we say the height was?
12.
Okay. Everybody remember how to start this off? What you do? So what's 5 squared plus 5 squared? 25, isn't it? So d squared equals 5 squared plus 5 squared. D squared equals 50. D equals root 50, which is, what's root 50? 5 root 2. Okay. What does that mean about this red distance here then? Call this distance b. 5 root 2 over 2. Question? Yeah, you can. Now, what do we have here then? Oh, sorry, I'll do it better. Pyramid questions happen a lot, so you'd want to be pretty good at them. That's the green side, that's the blue side, and that's the black side, alright? What's the size of the blue one?
5 root 2.
Okay. What's the size, therefore, of the black one? Anybody know? Black one, anybody? So we're going to do, call it L. L squared equals 5 squared plus 5 root 2 over 2 squared. Lob it in and get L. What is it?
Would it be 12 squared?
Huh?
Would it be 12 squared instead of 5 squared?
Oh, sorry, 12 squared, yes. Thank you, Vic. Sorry, it's the height, not the base length. What you get for that, Mick?
12.5.
What? 12.5? For L, yeah? Alright. Lads, how do we lock this out then? How'd you finish that off? It's all 12.5s, what can you do then? So that's 12.5. You're also 12.5. You're 5. Does anybody know a different way of getting the area of a triangle without doing a half base by height? There's a formula in your notes that does it as well. I'll show you it now just to cover more topics with you. Here's another way of doing this without doing a half base times height. Imagine this wasn't an isosceles or equilateral triangle. What other options would you have? Some people would get the cosine rule, find an angle, and then use a half AB sine C. There is one like this. It's A plus C. Is that it there? And then it's in your tables. And it's S minus A, S minus B, and S minus C. You're probably looking at that going, why on God's green earth would you do that? Okay? First things first. What is the S value? Lads, pick any three sides to be called A, B, C. Go for it. A, B, C. What's the three of them added together? What's 3 divided by 2? 15. S value is 15. Now the A value is 15. Now what's S take away A? What's 15 take away A? What's 15 take away B? And finally, what's 15 take away C? Throw all that into the calculator, what you get? You should get the area of one triangular face. We hope. And it is. Make me work it today, lads. $30.62. Alright. Lads, how many different sides is there? 4. Multiply by 4. Add on the square base. The square base is 5 by 5, which is 25. Wait a second. Multiply by 4. Add 25. 147.47 or 148. Actually rounds downwards. They got 148, I got 147. I think I'm more accurate. Alright, go outside before you zone. Alright guys, the pyramid shown opposite. Now, anyways, now, I could have won that. No, anyways, the pyramid shown opposite has been cut from a square base pyramid. Oh, so it's literally half a square base pyramid, is it? Imagine a square base pyramid and you cut it in half. So, if you will, if I was to continue that along, it looks something like that. But you cut that part off, so it's actually just it's half of it. Okay. Do we not already have the answer for a square base pyramid? Yeah. It's the volume of a square base pyramid, not 1/3 a squared h, where a was the bottom. So in that case, the full square pyramid would be 1/3 m squared h, but we have half a pyramid, not a full pyramid. So would that not be 1/6 m squared h? Oh, it is. Happy days. But one thing to note. The height is also m. So it's going to be m squared times m, and it's half of it, which is over 2, which is m cubed over 6. Oh, that was a lot easier than I thought it was going to be.
Do you have to get the back side as well?
Volume, not area, currently. So we're okay thus far. Okay. Describe this pyramid. This pyramid is half a square base pyramid, and it's made up of how many triangles do you reckon it's made up of? Your base triangle, which we'll call A, your front triangle, which is B. Would everybody agree that B and C are exactly the same size? And then the triangle at the back, which is what? Triangle at the back, which is side D. Is that right? So 4 triangles it's made up of. A base triangle A. A is this one here, in yellow. D is the one at the back, which is the blue triangle. And then if we're getting technical, B would be this one here. And then C is the other one. Is that okay? Now I'm going to obviously have to try and draw that now, haven't I? So that's going to be all the rage. So let's start off with the A. So what can we do for A? It's A is easy enough to draw. We're cool with that, right? Now we're going to draw B coming out of that then, right? So that's your A. And now we're going to try and draw B. So B will come out and it will be something like this. Your B. Okay. And B and C have to be the same size, don't they? So if you will, see this, if you're struggling to picture this, see that blue line? I'm folding C outwards. Okay? And see this green line? I'm folding B outwards over it. Okay? And then finally, this purple line at the back, I'm folding D outwards into the page. So that will be, I think D is a bit bigger, is it? Yeah. not that big though. That's extreme. But D. Alright guys. Now. Alright guys. Now. What does want to do with this? Draw its net and find the total surface area in terms of M. So unfortunately for us, we're going to have to figure out all the different sizes now, okay? Which isn't going to be so fun. So let's start from scratch. Alright. What did we learn from earlier about the square pyramid? So this used to be a square pyramid, didn't it? So what I'm going to do is I'm going to calculate this length here. Anybody tell me how to calculate that length? What do you reckon? Pythagoras theorem. Call it length x. So what's x squared equals? M squared plus m squared. X squared equals 2m squared. X equals root 2 m. Is that okay? Root 2m. Okay. So we know that you're m. We know that you're m. And then we know that you are root 2m. Okay. Next thing I could do with known is the length of this red line. See, everybody see this red line here? Okay. And it's going to be the same in all directions. That red line, doesn't matter which one it is, they're all three of them are the same size. So if I get one of them, I get all three of them. So let's work out the red line then. So what can we say about the red line, lads? What do we know about the height? It's m. What do we know about this blue distance here? 2 root 2 over 2 m, isn't it? And call this L. So what can we say then? L squared equals m squared plus 2 root 2 over 2 m. I just ignore the m's. Ignore m even exists. And just do 1 squared plus 2 root 2. Did anybody get this one out the other night? Oh, yeah. yeah, just the 2's will cancel, won't they? Leaving root 2. Haven't made a mistake, but I could have just done that, couldn't I?
I could be wrong, but not just root 2m in the first place.
When you half it is. I got the full diagonal. When you half the diagonal, it's root 2.
Yeah, but was the triangle you're using not n on both sides of 5 opposite?
Oh, sorry, yeah. Sorry, my bad. Oh, x is root 2m. My bad. So it's sorry, that's root 2m. Thanks, Jamie. That's root 2m. And half of root 2m is root 2 over 2m. Alright? And that will bring me back to my red line from earlier. Thanks for that. Red. Blue. Green. Alright guys. So we're calculating the red side now, okay? So m in height, root 2 over 2 is just m over root 2, isn't it? But we won't complicate things. Root 2 over 2 m. And we're looking for L. L squared equals m squared plus root 2 over 2 m squared. Alright, just going to lock this in. Just get rid of the 2 there. 3 over 2. So L equals 3 over 2 m squared. So L equals root 3 over 2 m. Happy days. We have that now, don't we? Okay. Oh God. Now. So what's that? What does that mean? That's root 3 over 2m. That's root 3 over 2m. That's root 3 over 2m. Does it want me to get the entire area? Oh dear God. Alright. Do you know what I'd do in this situation? Give up. But apart from that, pretty much give up. I would not do Pythagoras' theorem. I would not go near it. Right? It's very complicated. So I'd actually end up going back to this one here. And I'd use my storage facilities to do it. You know what I'm saying about the storage? Would everybody be able to take it from here though? As in, no. You would know how to attempt it from here on in though, would you? Grand. I think I'm wasting my time at this stage.